There's something almost magical about looking up at the night sky, a feeling that transcends time and place. For thousands of years, humans have gazed at those same stars, tracing patterns in the darkness, weaving stories, and searching for meaning in the infinite. What if I told you that every constellation, every eclipse, every meteor shower isn't just a celestial event, but a thread in the grand tapestry of human history? Today, we're embarking on a journey through 25 unforgettable cosmic narratives that merge history and the heavens, where the stars above become mirrors reflecting our own triumphs, fears, and endless curiosity. Think about the last time you stood beneath a sky so clear it felt like you could reach out and touch the Milky Way. That same awe has echoed across centuries, from Babylonian priests charting planetary motions to Galileo turning his telescope toward Jupiter's moons, from Polynesian navigators guided by the stars to the engineers who launched Voyager beyond our solar system. These aren't just isolated moments of discovery, they're chapters in a story that connects us all. The heavens have shaped empires, inspired revolutions, and even dictated the rise and fall of civilizations. And yet, the cosmos remains a mystery, inviting us to keep exploring, to keep asking questions. This video is your portal to those stories, each one a collision of human ambition and cosmic wonder. We'll unravel how a supernova witnessed in China over 1,000 years ago altered the course of astronomy, how the alignment of celestial bodies influenced the construction of ancient temples, and how a single comet might have changed the fate of kings. These tales aren't just about what's out there, they're about who we are, because every time we look up, we're not just observers, we're part of the narrative. So let's begin this journey together, where history and the heavens dance in perfect harmony, and where the universe reveals its most unforgettable secrets. One of the most enduring cosmic mysteries begins with a single light in the night sky, a beacon so powerful it shaped the course of human history. The Star of Bethlehem, mentioned in ancient texts as a sign of monumental change, has sparked debate for over 2,000 years. Was it a miraculous celestial event, or could science offer an explanation? Some astronomers point to rare planetary conjunctions, like the alignment of Jupiter and Saturn in the constellation Pisces around the year 7 before the Common Era. This dazzling meeting of planets would have shone bright enough to catch the attention of stargazers, possibly even the biblical Magi. Others argue it might have been a supernova, a dying star's explosive finale, illuminating the heavens with unmatched brilliance. Then there are those who believe no scientific explanation can fully capture the star's significance. Across centuries, artists have painted it with golden radiance, poets have woven it into verses of hope, and theologians have seen it as a divine marker, proof of the extraordinary intersecting with the ordinary. The star didn't just guide wise men, it became a symbol, a story retold in countless cultures, shaping traditions from Christmas carols to Renaissance masterpieces. Yet what makes this cosmic event truly unforgettable isn't just the debate over its origins, it's the way it bridges faith and science, wonder and reason. Whether a natural phenomenon or something beyond our understanding, the Star of Bethlehem reminds us that the heavens have always been more than just distant lights. They're mirrors of our deepest questions, our myths, and our longing to find meaning in the vast unknown. And perhaps that's the real magic, not in solving the mystery, but in the way it continues to inspire us, century after century, to look up and wonder. The night of April 24, 1066, marked a celestial event that would ripple through history, a brilliant streak of light blazing across the heavens, its tail stretching like a silver sword. Halley's Comet, returning as it does every 76 years, wasn't just another astronomical phenomenon that year. To the people of medieval Europe, it was a portent, a divine sign etched into the sky. And nowhere is this moment more vividly captured than in the Bayeux Tapestry, that extraordinary embroidered chronicle of the Norman conquest of England. There, woven into the fabric itself, the comet hovers ominously above terrified onlookers, its presence interpreted as a blessing for William the Conqueror's audacious invasion. But why did a comet, a predictable visitor to our solar system, hold such power over human destiny? To understand, we have to step into the minds of 11th century observers. For them, comets weren't just celestial objects, they were messengers, disruptors of the natural order. Ancient records from Rome to China describe comets as omens of upheaval, harbingers of war, the death of kings, or the fall of empires. When Halley's Comet appeared in 1066, it didn't just coincide with history, it became part of the story. King Harold of England reportedly saw it as a sign of his impending doom, while William the Conqueror spun it as divine favor, a cosmic endorsement of his claim to the throne. The tapestry immortalizes this duality, showing crowds pointing in fear even as William's ship set sail, propelled by destiny, or perhaps by the psychological weight of a sign in the sky. What's fascinating is how science and superstition intertwined in this moment. Today, we know Halley's Comet as a snowy ball of dust and ice, tracing its elliptical path around the sun. But back then, its sudden appearance defied explanation, leaving room for myth and manipulation. The comet's role in the Norman victory wasn't just about celestial mechanics. It was about perception, the stories people told themselves to make sense of chaos. And that's the real lesson here. The heavens don't dictate our fate, but they've always held up a mirror to our fears, ambitions, and the narratives we cling to in times of uncertainty. The Bayeux Tapestry gives us something rare, a snapshot of how cosmic wonders shaped human history in real time. It's not just a record of battles and kings, it's proof that the sky has always been a canvas for our hopes and dread. Halley's Comet didn't decide the outcome of the Norman conquest, but its fiery passage across the medieval sky became a character in the drama, a reminder that sometimes history isn't just written on parchment, it's written in the stars. In the summer of 1054, a new light appeared in the heavens, one so dazzling it could be seen even at midday. Chinese astronomers of the Song dynasty called it a guest star, an unexpected visitor in the constellation Taurus. Their meticulous records describe it shining with an intensity rivaling Venus, visible for nearly 2 months before fading into the night. But across the Pacific, another culture may have witnessed the same cosmic spectacle. Petroglyphs carved into rock by ancestral Pueblones in what's now the American Southwest depict a star beside a crescent moon, a configuration matching the supernova's position relative to the moon on July 5th of that year. What makes this celestial event extraordinary isn't just its brilliance, but how differently these cultures interpreted it. To the Chinese court astronomers, it was an omen demanding careful documentation. Their records, preserved in imperial archives, noted its color, position, and duration with scientific precision. Meanwhile, oral traditions from indigenous North American tribes suggest the star was woven into creation stories, a celestial ancestor or a sign of transformation. The same explosion that inspired bureaucratic notation in one hemisphere might have sparked sacred storytelling in another. Today, we know this event as the birth of the Crab Nebula, a swirling remnant of that dying star, its filaments still expanding into space. Modern telescopes reveal intricate details unseen by those 10th century observers. shockwaves glowing in X-rays, a pulsar spinning at its heart. Yet the real wonder lies in how a single cosmic moment became a mirror for human diversity. The supernova didn't change. What changed was how people saw themselves reflected in its light. For some, it reinforced the order of the cosmos under an emperor's mandate. For others, it might have symbolized the fluid boundaries between the spiritual and the celestial. This duality captures something profound about our relationship with the heavens. The universe gives us raw phenomena, explosions, eclipses, meteor showers, but it's human imagination that turns them into meaning. The Crab Nebula isn't just a scientific curiosity. It's a testament to how the same starlight can illuminate entirely different worlds of thought. And perhaps that's the most beautiful lesson of all, that astronomy isn't just about studying distant objects, but understanding how their light echoes through the tapestry of human culture, connecting us across time and space in a shared dance of wonder. In the winter of 1610, a humble telescope in Padua, Italy, became the unlikely battleground for humanity's understanding of the cosmos. Galileo Galilei, a man driven by insatiable curiosity, turned his newly improved instrument toward Jupiter, and what he saw would shake the foundations of knowledge itself. 4 tiny points of light danced around the gas giant, moving in perfect rhythm. These weren't stars, they were moons orbiting Jupiter just as our moon orbits Earth. At that moment, the universe expanded in ways no one had dared imagine. If celestial bodies could revolve around something other than Earth, perhaps our planet wasn't the immovable center of creation after all. This revelation didn't just challenge astronomy, it threatened an entire worldview. For centuries, the Church had upheld the Ptolemaic model, where Earth sat motionless at the heart of God's orderly universe. Galileo's discovery didn't merely add new objects to the sky, it implied a cosmos far more complex, dynamic, and unsettling than authorities were prepared to accept. When he published his findings in the Starry Messenger, the backlash was swift. Some scholars dismissed his work as optical illusions or heresy. Others, like Cardinal Bellarmine, warned him to treat his ideas as hypothetical, a polite way of saying, "Stop rocking the boat." But Galileo, ever the provocateur, pushed further. His later book, Dialogue Concerning the Two Chief World Systems, openly mocked the old Earth-centered model, framing it through the voice of a buffoonish character named Simplicio. The insult wasn't subtle, and neither was the Church's response. What followed was one of history's most infamous confrontations between science and dogma. In 1633, an aging Galileo stood trial before the Roman Inquisition, accused of defying scripture. The charges weren't just about astronomy, they were about authority. To admit Earth wasn't central was to admit that holy texts might need reinterpretation, that human observation could challenge divine truth. Forced to recant under threat of torture, Galileo famously muttered, "And yet it moves," a defiant whisper against the weight of orthodoxy. He spent his final years under house arrest, forbidden from publishing, yet his ideas couldn't be imprisoned. What makes this clash so enduring isn't just the drama, it's the deeper questions it forces us to confront. How do we reconcile faith with evidence? When does tradition become obstruction? Galileo's story isn't merely about a man versus an institution. It's about the courage to trust observation over doctrine, even when the cost is unimaginable. His telescope didn't just reveal moons around Jupiter, it revealed something far more profound: the fragility of human certainty. Centuries later, we celebrate Galileo as a martyr for science, but his legacy is more nuanced. The Church eventually acknowledged its error, yet the tension he embodied never fully vanished. Every generation faces its own version of this struggle, whether debating evolution, climate change, or artificial intelligence. The heavens remind us that truth isn't always comfortable, and progress often demands discomfort. Galileo's moons still orbit Jupiter, silent witnesses to a simple truth. The universe refuses to shrink itself to fit our assumptions. And perhaps that's the most revolutionary idea of all, that humility, not certainty, is the real key to the cosmos. The year 1811 began with an ordinary winter sky until September, when a luminous stranger emerged from the darkness. The Great Comet of 1811 wasn't just another celestial visitor. It was a spectacle so vivid it dominated the night for nearly 260 days, its tail stretching like a celestial brushstroke across the heavens. Visible even in broad daylight at its peak, the comet became a global obsession, sparking everything from artistic masterpieces to battlefield superstitions. In an era without electric lights to dim the stars, its brilliance felt apocalyptic, a cosmic interruption that demanded interpretation. Napoleon Bonaparte, then at the height of his power, reportedly saw the comet as a personal omen, a celestial endorsement of his invasion of Russia. His soldiers marched eastward beneath its glow, whispering that it heralded victory. History, of course, had other plans. The disastrous campaign that followed, with its brutal retreat through the Russian winter, would later make the comet's appearance seem less like a blessing and more like a warning. But Napoleon wasn't alone in his cosmic optimism. Across Europe, winemakers celebrated the comet's influence, claiming it gifted the year's grapes with unparalleled richness. To this day, bottles labeled Comet wine from 1811 fetch astronomical prices at auctions, a testament to the enduring myth of celestial favor. Artists, too, were captivated. The comet's ethereal beauty found its way into paintings by John Linnell in England and Caspar David Friedrich in Germany, each interpreting its glow through their own cultural lens. Poets like Lord Byron wove it into verses, while Beethoven, struck by its majesty, reportedly composed passages of music with its rhythm in mind. Even farmers' almanacs recorded its movements alongside weather predictions, blending practicality with wonder. What makes this comet's legacy so fascinating isn't just its brightness, it's the way it reveals humanity's instinct to seek meaning in the skies. Unlike Halley's Comet, whose returns are predictable, the Great Comet of 1811 was a surprise guest, arriving unannounced in a world already trembling with change. The Napoleonic Wars, the Industrial Revolution, the rise of Romanticism, all these upheavals framed how people viewed its passage. For some, it symbolized divine judgment, for others, inspiration. Science, of course, offers its own explanation. We now know the comet's spectacular display came from an unusually large nucleus, venting gas and dust as it neared the sun. But reducing it to icy debris misses the point. The true magic of 1811 lies in how a ball of rock and ice became a canvas for human dreams, fears, and ambitions. It reminds us that the cosmos doesn't just exist above us, it lives within us, shaping culture, sparking creativity, and even, perhaps, whispering to generals before their fateful decisions. The Great Comet didn't change history, but for a fleeting moment, it made the universe feel intimately tangled with our own stories. And isn't that the most timeless wonder of all? On May 29, 1919, the sun vanished in the middle of the day, and for 6 precious minutes, the sky revealed a truth that would rewrite the laws of physics. A total solar eclipse draped parts of Africa and South America in darkness. But this wasn't just a celestial spectacle. It was a cosmic experiment, one that would test the boldest idea of the 20th century, Einstein's theory of general relativity. The stakes couldn't have been higher. If the universe really worked the way Einstein predicted, starlight passing near the sun would bend, warping along the curves of space-time like a marble rolling across a stretched sheet. And the only way to see it, wait for the moon to block the sun's glare, revealing stars that shouldn't be visible in daylight, stars whose positions would tell the tale. Two teams of astronomers, led by Arthur Eddington and Frank Dyson, embarked on expeditions to capture this moment. One group set up in Sobral, Brazil, the other on the remote island of Principe off Africa's coast. Their tools were simple by today's standards: telescopes, photographic plates, and a desperate hope for clear skies. Principe's team battled rain until the very last moment, their hearts sinking as clouds threatened to obscure the eclipse. Then, like a curtain lifting, the sky cleared just in time. The photographs they took weren't just scientific records, they were snapshots of a paradigm shift. When the plates were developed, the results were undeniable. Stars near the sun's edge appeared slightly out of place, their light deflected by the sun's gravity, exactly as Einstein had calculated. What makes this eclipse unforgettable isn't just the science, it's the drama surrounding it. Einstein, then a rising but still controversial figure, had published his theory in 1915, proposing that gravity wasn't a force but the curvature of spacetime itself. To many, it sounded like pure imagination. Even Eddington, who championed the theory, faced skepticism from colleagues who clung to Newton's model. When the eclipse confirmed Einstein's predictions, the news didn't just spread through academic circles, it exploded into global headlines. "Lights all askew in the heavens," declared the New York Times, capturing the public's awe. Suddenly, relativity wasn't just an abstract equation, it was a tangible reality, proven under the shadow of the moon. But the real magic of this story lies in its symbolism. The eclipse became more than a validation of Einstein's genius. It was a triumph of human curiosity over intuition. Newton's laws had governed physics for centuries, offering a clockwork universe where space and time were absolute. Einstein's universe was fluid, dynamic, almost poetic in its interconnectedness. The eclipse didn't just bend starlight, it bent humanity's understanding of reality, and in doing so, it revealed something profound, that the cosmos operates on rules far stranger and more beautiful than we'd ever dared to dream. Today, we remember the 1919 eclipse as the moment science leaped into the modern age. Yet it's also a reminder that breakthroughs often hinge on patience, precision, and a bit of celestial luck. Those 6 minutes of darkness illuminated a truth hidden in plain sight, that the universe is a vast, malleable fabric, and we're all just threads woven into its grand design. And perhaps that's the most humbling lesson of all. Sometimes to see the light, we first need the sky to go dark. On the morning of June 30th, 1908, a fireball streaked across the Siberian sky with the force of 1,000 suns. Near the Podkamennaya Tunguska River, reindeer herders saw a blinding column of light split the heavens, followed by a shockwave so powerful it hurled people off their feet and flattened 80 million trees across 800 square miles. Windows shattered hundreds of miles away. Seismic stations across Europe recorded tremors. Nights for weeks afterward glowed strangely as far away as London skies, so bright people could read newspapers at midnight. Yet when scientists finally reached the remote site 19 years later, they found no crater, no fragments of rock or metal, just a bizarre radial pattern of fallen trees, their trunks scorched bare, pointing away from an invisible epicenter. What caused the Tunguska event remains one of the most tantalizing cosmic whodunits. The leading theory suggests an asteroid or comet roughly 60 meters wide exploded 5 to 10 kilometers above the ground, its shockwave mimicking a nuclear detonation. But without physical remnants, certainty eludes us. Some researchers propose it was a fragment of comet in Care, part of an annual meteor shower. Others speculate about more exotic explanations, a chunk of antimatter annihilating on contact with our atmosphere, or even a microscopic black hole passing through Earth. The absence of definitive evidence keeps the mystery alive, fueling debates at scientific conferences and late-night conspiracy theories alike. What makes Tunguska unforgettable isn't just the scientific puzzle, it's the chilling reminder of our planet's fragility. Had the object arrived just 4 hours later, it could have obliterated St. Petersburg or London, rewriting history in an instant. Modern simulations estimate such events occur every few centuries and with far more frequency than larger, dinosaur-killing impacts. NASA now tracks near-Earth objects, while projects like the DART mission test our ability to deflect future threats. Yet Tunguska endures as a humbling lesson. The universe doesn't operate on human timelines. The event also birthed an odd cultural legacy. Soviet propaganda initially dismissed it as a capitalist hoax, while later expeditions turned it into a nationalist symbol of scientific prowess. In Siberia, indigenous Evenki people wove the explosion into their oral traditions, interpreting it as the wrath of the fire god Ogdi. Today, Tunguska-inspired art, music, and even video games imagine alternate scenarios. What if it had been an alien probe or a rift in space-time? Perhaps the most profound takeaway lies in the silence of that empty epicenter. Tunguska didn't just flatten trees, it exposed how thin the line is between ordinary days and cosmic catastrophe. The same skies that inspire poetry and navigation can also deliver chaos without warning, and in that tension between awe and vulnerability, we find a truth as old as humanity itself. The universe writes its stories in fire and ice, and we're left deciphering the ashes. In the summer of 1977, as disco music pulsed through Earth's nightclubs and the first home computers flickered to life, 2 robotic explorers embarked on a journey unlike any other. The Voyager probes, designed to study the outer planets, carried with them more than just scientific instruments. Nestled within each spacecraft was a golden record, a 12-inch copper disc plated with gold, etched with symbols, and filled with the sounds and images of a planet brimming with life. These weren't just technical artifacts, they were time capsules, love letters flung into the cosmic ocean, meant to outlast not just their creators but perhaps humanity itself. The concept was as bold as it was poetic. Carl Sagan and his team had less than a year to decide what to include, a snapshot of Earth for beings who might never understand our languages, our cultures, or even our biology. The result was a mesmerizing collage, greetings in 55 languages, from ancient Akkadian to modern Wu, the haunting strains of a Navajo night chant and Bach's Brandenburg Concerto, the roaring liftoff of a Saturn V rocket, and the gentle crackle of a mother's kiss. Images encoded on the records ranged from mathematical diagrams to a supermarket aisle, from a Tibetan monk to a ballet dancer mid-leap. Even the record's cover carried instructions in symbolic language, a pulsar map pointing back to Earth, and a diagram showing how to play the sounds encoded in its grooves. But what makes the golden records truly extraordinary isn't just their contents, it's the philosophy behind them. Sagan insisted the records avoid any trace of war, politics, or division. Instead, they celebrated curiosity, creativity, and connection. A chimpanzee's laughter sits alongside a Peruvian wedding song. A heartbeat shares space with the calls of humpback whales. The message was clear: Earth's greatest treasures aren't its technologies or borders, but its capacity for wonder and its chorus of diverse voices. Critics called it quixotic. The chances of extraterrestrials finding these tiny probes in the vastness of space are vanishingly small. Even if discovered, could beings of another world decipher waveforms etched onto a disk? Yet the records were never really about practicality. They were a mirror held up to humanity, asking, What do we value enough to send to the stars? What defines us when stripped of daily trivialities? Today, the Voyagers have left our solar system, becoming the first human-made objects to enter interstellar space. Their cameras long dormant, their power fading, the golden records remain intact, silent ambassadors drifting through the void. They carry no updates, no tweets, no news of climate change or global conflicts. They're frozen in the optimism of 1977, a moment when humanity dared to imagine it might one day greet the cosmos not with fear, but with open hands. Perhaps the most poignant lesson of the golden records lies in their timelessness. Long after skyscrapers crumble and languages fade, these disks will still whisper of Earth, a pale blue dot that once teemed with life, its people flawed yet striving, its cultures fractured yet united by the same sky. They remind us that exploration isn't just about discovering new worlds, it's about understanding our own, and in that act of reaching outward, we might just find what it means to be human. The year 1968 was one of turmoil, protests, war, political assassinations, a planet seemingly tearing itself apart. Yet on Christmas Eve, as Apollo 8 emerged from behind the moon's barren surface, something extraordinary happened. Astronaut Bill Anders lifted his Hasselblad camera and captured a single frame that would change humanity's view of itself forever. Earth, a vibrant blue and white marble, rising over the lunar horizon against the endless black of space. The Earthrise photo wasn't just a technical achievement. It was an emotional lightning strike, revealing our world not as a map of borders and conflicts, but as a solitary, fragile oasis adrift in the cosmic dark. What made this image so revolutionary wasn't just its beauty, but its timing. For the first time, humans had traveled far enough to see their home planet whole, and the contrast couldn't have been starker. The moon beneath Apollo 8's windows was a desolate wasteland, pocked with craters, devoid of life or atmosphere. Earth, by comparison, glowed with color and motion, its swirling clouds and oceans a testament to the improbability of existence itself. Astronaut Frank Borman later described the moment as the most beautiful, heart-catching sight of my life, while James Lovell reflected on how everything you've ever known is behind your thumb. The crew, trained to study the moon, found themselves transfixed by the view behind them. Back on Earth, the photo landed like a revelation. Newspapers splashed it across front pages. Environmental movements adopted it as a rallying cry. For a generation raised on images of division walls, wars, ideological chasms, Earthrise offered a counter-narrative, unity. There were no lines marking nations, no flags or factions, just a delicate sphere suspended in nothingness. Poet Archibald MacLeish captured the sentiment in the New York Times, writing, "To see the Earth as it truly is, small and blue and beautiful in that eternal silence where it floats, is to see ourselves as riders on the Earth together." Science historians often call this the overview effect, the cognitive shift astronauts experience when seeing Earth from space. But Earthrise democratized that perspective. It became a mirror held up to humanity, exposing both our planet's vulnerability and our shared responsibility for it. Within months of the photo's release, the first Earth Day was organized. The environmental movement gained unprecedented momentum, and even policymakers cited the image as inspiration for landmark conservation laws. The photo's influence rippled into art, philosophy, and theology, challenging centuries of anthropocentric thinking. Yet the real power of Earthrise lies in its duality. It's at once a celebration and a warning, a reminder of how rare and precious life is in the cosmic scale, and how recklessly we've treated our only home. The Apollo missions were born from Cold War competition, but they gifted us something far greater than political victory, perspective. That tiny, glowing disk in the void contains every human who ever lived, every story ever told, every forest and ocean and city. And for all our divisions, we're all just passengers on this pale blue dot, hurtling through space together. Decades later, Earthrise remains one of the most reproduced images in history, not because of its technical perfection, but because of the questions it forces us to confront. What does it mean to be stewards of such fragility? How do we honor the unity the cosmos reveals? The photo didn't just document a moment in space exploration. It expanded humanity's moral horizon. And perhaps that's the true legacy of Apollo 8, not that we reached the moon, but that from its barren plains we finally saw ourselves. When Christopher Nolan's Interstellar hit theaters in 2014, audiences weren't just treated to a sci-fi epic. They witnessed one of the most scientifically accurate depictions of a black hole ever created. Behind this cinematic marvel stood physicist Kip Thorne, whose equations shaped the film's iconic black hole, Gargantua, into a swirling vortex of light and spacetime. The collaboration between Hollywood and hard science didn't just make for stunning visuals. It pushed the boundaries of astrophysics itself. Thorne's work with the visual effects team led to discoveries so novel they were published in peer-reviewed journals, proof that art and science don't just coexist, they can amplify each other in unexpected ways. What made Gargantua so groundbreaking was its realism. Previous films had portrayed black holes as ominous voids or swirling portals, but Interstellar's version was different. Using Thorne's calculations, the effects team rendered the black hole's accretion disk, a superheated ring of gas and dust with unprecedented precision. The result was a mesmerizing halo of light, warped by gravitational lensing into a glowing crown around the abyss. Even the way light bent around Gargantua followed Einstein's equations, creating a distortion effect so accurate it left astrophysicists in awe. For the first time, moviegoers weren't just seeing a black hole, they were seeing how one might actually look if they could stand at the edge of spacetime. But the real magic lay in the unintended discoveries. As the team simulated Gargantua's appearance, they noticed something strange. The light around the black hole formed intricate patterns, like fingerprints in the fabric of the universe. These weren't just artistic flourishes, they were visual manifestations of complex gravitational interactions. Thorne realized the simulations had uncovered phenomena that hadn't been described in scientific literature. The film's imagery became so influential that it changed how scientists visualized black holes, inspiring new research into how their extreme gravity warps light. Beyond the science, Interstellar did something equally profound. It made the cosmos feel personal. By grounding its spectacle in human emotion, the film turned abstract physics into a visceral experience. When Matthew McConaughey's character falls into Gargantua, the audience doesn't just see a scientific anomaly, they feel the terror and wonder of confronting the unknown. The Tesseract sequence, where time becomes a physical dimension, transformed fourth-dimensional theory into a father's desperate attempt to reach his daughter across the years. This emotional resonance is what set Interstellar apart. It didn't just teach viewers about relativity, it made them feel it. The legacy of Gargantua extends far beyond the silver screen. Schools now use clips from Interstellar to explain gravitational physics, while Thorne's book on the science behind the film became a bestseller. The project proved that pop culture could be a gateway to complex ideas, sparking curiosity in ways textbooks alone never could. And perhaps that's the most revolutionary part of this cosmic narrative, not just that science inspired art, but that art, in turn, inspired a new generation to look up at the stars and ask, what if? What began as a Hollywood blockbuster became a testament to the power of collaboration. Interstellar didn't just entertain, it expanded our collective imagination, showing that the universe's greatest mysteries aren't just for scientists in labs. They're stories waiting to be told, shared, and marveled at by everyone. And in that shared wonder, we find the true magic of the cosmos. It was an ordinary summer night in Ohio, 1977, when the universe seemed to speak, just once and never again. At 1:30 in the morning on August 15th, a radio telescope at Ohio State University's Big Ear Observatory picked up a signal so unusual that astronomer Jerry Amon circled it in red pen on the printout, scribbling a single word beside it: "Wow." What made this blip of static extraordinary wasn't its duration. It lasted just 72 seconds, but its intensity and frequency. The signal blasted through the narrowband at 1420 MHz, a range where natural cosmic noise is virtually silent, reserved by international agreement for scientific listening. It matched the exact profile astronomers predicted for an artificial transmission from deep space. For decades, the WOW signal has tantalized scientists and dreamers alike. Its origin appeared to lie near the constellation Sagittarius, in a region devoid of known stars or planets. No natural phenomenon, no pulsar, no quasar, no passing comet has ever been found to explain it. The signal's structure was equally baffling. It followed a precise pattern, rising and falling in strength exactly as you'd expect if it came from a distant source drifting into and out of the telescope's field of view. And then, just as suddenly as it arrived, it vanished. Despite dozens of follow-up scans, the signal never repeated. Skeptics have proposed theories, of course. Some argue it was a reflected human transmission, a satellite or military experiment bouncing off space debris. Others suggest it was a glitch, an anomaly in the telescope's aging hardware. But none of these explanations fully account for the signal's unique characteristics. The frequency, the duration, the location all point to something far more intriguing. In 2016, astronomer Antonio Paris proposed a new hypothesis. A passing hydrogen cloud from two comets might have emitted the signal. Yet when researchers tested this idea, the math didn't align. The comets weren't in the right position that night. What gives the WOW signal its enduring mystique isn't just the unanswered questions. It's the way it crystallizes the essence of our cosmic curiosity. For 72 seconds, the universe seemed to whisper, "You're not alone," before retreating into silence. That fleeting moment galvanized the search for extraterrestrial intelligence, inspiring projects like SETI to scan the skies with renewed urgency. It's a reminder that the cosmos is vast beyond comprehension, and yet, somewhere in that immensity, there might be another voice calling out, not in malice or conquest, but in the same spirit of wonder that drives us to look up and listen. The WOW signal didn't just challenge our understanding of the universe, it challenged our place within it. Whether it was an alien greeting or a cosmic fluke, one thing is certain. For those 72 seconds, the universe felt a little less empty. And perhaps that's the real lesson, not that we've found proof of others, but that we're still brave enough to keep searching. Long before telescopes or star charts, humanity found meaning in the wandering lights of the night sky, patterns so familiar they became characters in an eternal cosmic drama. The Zodiac, that celestial belt divided into 12 signs, began not as a newspaper horoscope, but as a sacred map etched by Babylonian astronomers over 2,500 years ago. These ancient stargazers noticed something peculiar. The sun, moon, and planets didn't move randomly. They traveled along a fixed path, passing through the same constellations year after year. To the Babylonians, this wasn't mere coincidence. It was a divine script written in the stars for those who could read it. What's fascinating is how this system evolved across cultures. The Greeks adopted the Babylonian zodiac but infused it with their own mythology. transforming constellations into heroes and beasts, Aries the ram from the Golden Fleece, Scorpio sent by Artemis to slay Orion. In India, Vedic astrology wove the zodiac into spiritual practice, tying planetary alignments to karma and reincarnation. Even the Maya, half a world away, developed their own zodiac-like system, linking celestial cycles to agricultural rituals and royal coronations. Despite oceans and epochs separating these civilizations, they all shared a common impulse to see the heavens not just as lights, but as mirrors reflecting human destiny. Yet the zodiac's greatest legacy might be its stubborn persistence in the face of scientific scrutiny. By the 17th century, astronomers like Kepler knew the planets moved according to gravity, not divine will. Modern astronomy reveals that the constellations themselves are an illusion, stars grouped by perspective, not actual proximity. Even the zodiac's alignment has shifted due to Earth's wobble, creating a 13th constellation, Ophiuchus, ignored by traditional astrology. And yet, 2 millennia after Babylon, millions still check their horoscopes, attend astrology-themed parties, or name children after celestial signs. This contradiction between scientific dismissal and cultural embrace reveals something profound about human nature. The zodiac endures not because it predicts the future, but because it offers a language for our deepest questions. Why do we suffer? Who should we love? When will luck turn? In a chaotic world, the stars provide a story, a sense of order imposed on randomness. Even skeptics find themselves drawn to the archetypes, the bold Aries, the nurturing Cancer, not as fate, but as tools for self-reflection. Perhaps the real magic of the zodiac lies in its adaptability. From Babylonian priests to TikTok astrologers, each generation reinvents the stars to fit its needs. The constellations haven't changed, but how we see ourselves within them always does. And in that endless reinterpretation, we find a truth as old as the night sky, that humans will always look upward, not just to navigate, but to understand who we are. For centuries, astronomers gazed at the stars with a singular question burning in their minds: are there other worlds like ours out there? In 1995, that question finally got an answer. Swiss astronomers Michel Mayer and Didier Queloz pointed their telescopes at 51 Pegasi, a sun-like star 45 light-years away, and detected something extraordinary: a slight wobble in the star's motion, a telltale sign of an orbiting planet. But this wasn't just any planet. 51 Pegasi b, as it came to be known, defied all expectations. A gas giant half the size of Jupiter, it orbited its star in just 4 days, so close that its surface temperature could melt iron. This wasn't the orderly solar system we knew. It was a cosmic oddball, proof that the universe had surprises up its sleeve. The discovery shattered centuries of assumptions. Before 51 Pegasi b, scientists had assumed other solar systems would resemble ours: rocky planets close to the sun, gas giants farther out. But here was a hot Jupiter, a planet so massive and so close to its star that it rewrote the rulebook overnight. The floodgates opened. Within a decade, new detection methods like the transit technique, which measures the dimming of a star as a planet passes in front of it, revealed hundreds more worlds. Some orbited 2 stars at once, like Luke Skywalker's home planet Tatooine. Others, like the diamond planet 55 Cancri E, were so dense they might be made of crystallized carbon. Then came the real stunners: rocky planets in the Goldilocks zone, where temperatures could allow liquid water, and with it, the potential for life. The Kepler Space Telescope, launched in 2009, turned this trickle of discoveries into a tidal wave. For 9 years, Kepler stared at a single patch of sky, monitoring the brightness of over 150,000 stars. Its findings were nothing short of revolutionary: thousands of confirmed exoplanets, with billions more likely scattered across the Milky Way. Among them was Kepler 438b, a rocky world with a 70% chance of being habitable, and Kepler 1625b, a super-Earth with possible water clouds. But perhaps the most tantalizing of all was the TRAPPIST-1 system, 7 Earth-sized planets orbiting a tiny red dwarf star, 3 of them sitting snugly in that life-friendly zone. What makes this exoplanet revolution so profound isn't just the sheer number of worlds, it's what they tell us about our place in the cosmos. For the first time in human history, we have statistical proof that planets aren't rare accidents. They're as common as stars themselves. The Milky Way alone could harbor tens of billions of Earth-like worlds. That realization has turned the search for life from a philosophical musing into a testable scientific endeavor. Projects like the James Webb Space Telescope now scan exoplanet atmospheres for biosignatures, molecules like oxygen or methane that could hint at biological activity. Even the way we talk about space has changed. Terms like habitable zone and Earth analog have entered the public lexicon, reshaping how we imagine our cosmic neighborhood. Yet the real magic lies in the questions these discoveries provoke. Could a planet with 2 suns develop life under double sunsets? Might a tidally locked world, where one side always faces its star, host extremophiles in the twilight zone between scorching day and frozen night? The diversity of exoplanets has forced us to expand our definition of habitable beyond Earth-centric assumptions. Life, it seems, might be more adaptable and more creative than we ever dreamed. The hunt for exoplanets is far from over. New missions like the European Space Agency's Pluto and NASA's Nancy Grace Roman Telescope promise to uncover even stranger worlds. But one thing is already clear: we live in a galaxy teeming with possibilities, where every star could be the sun to someone else's story. And as we keep searching, we're not just mapping the cosmos, we're rediscovering what it means to be a tiny, curious species in an unimaginably vast and wondrous universe. In 1964, 2 radio astronomers in New Jersey made a discovery so profound it would earn them a Nobel Prize, and it all started with pigeons. Arno Penzias and Robert Wilson were troubleshooting noise in a massive horn-shaped antenna at Bell Labs, convinced the interference ruining their experiments came from bird droppings. They scrubbed away every last trace of pigeon debris, even evicting the birds themselves, but the mysterious static remained, a faint, omnipresent hum that seemed to come from every direction in the sky. What they'd stumbled upon wasn't faulty equipment or avian interference. It was the cosmic microwave background, the afterglow of the Big Bang itself, cooling over 13.8 billion years into microwave whispers. This ghostly radiation is more than just ancient light. It's a time machine. The cosmic microwave background, or CMB, carries snapshots of the universe when it was just 380,000 years old, a searing plasma of particles too hot to form atoms. As the cosmos expanded and cooled, that plasma finally became transparent, releasing photons that have traveled unimpeded ever since. Today, those photons reach us as microwaves, their wavelengths stretched by the universe's expansion into a faint glow just 3 degrees above absolute zero. Mapping this glow is like reading the universe's baby pictures, revealing the primordial lumps and voids that would one day grow into galaxies and superclusters. The CMB's fingerprints are everywhere. In 2003, NASA Wilkinson Microwave Anisotropy Probe, or WMAP, produced a detailed map of its temperature fluctuations, tiny variations no larger than 1 part in 100,000. These imperfections are cosmic seeds, the gravitational wells where matter first clumped together, drawn by dark energy and dark matter we still barely understand. Later missions like Planck refined these maps further, turning abstract theory into precise measurements of the universe's age, composition, and even its ultimate fate. Yet the CMB's greatest gift might be its humility. It's proof that the grandest questions, how did everything begin, can be answered by studying the quietest signals. Penzias and Wilson weren't looking for the Big Bang. They were just persistent engineers chasing down noise. Their discovery reminds us that the universe's most profound truths often hide in plain sight, waiting for someone to listen closely enough. And perhaps that's the real lesson of the cosmic microwave background, not just that we've glimpsed the dawn of time, but that the cosmos still has countless whispers left for us to hear. Mars has always been more than just a red dot in the night sky. It's been a mirror for humanity's deepest hopes and fears, from Percival Lowell's feverish sketches of Martian canals to H.G. Wells' War of the Worlds. Our fascination with the fourth planet has always carried one burning question: could life exist beyond Earth? That question drove NASA's Viking missions in 1976. The first spacecraft designed explicitly to hunt for extraterrestrial biology. Viking's landers scooped up Martian soil, testing for microbial activity in experiments that still spark debate today. Some results hinted at chemical reactions that might suggest life, while others pointed to sterile, oxidizing soil. The ambiguity only fueled our obsession, setting the stage for decades of robotic explorers to pick up the torch. What makes Mars so tantalizing isn't just its proximity, it's the evidence etched into its rusty surface. Ancient river valleys, dried up lake beds, and mineral deposits that only form in water all whisper of a wetter, warmer past. If life ever took hold on Earth, why not here? This question birthed a lineage of rovers, each more sophisticated than the last. Pathfinder's Sojourner, no bigger than a microwave, proved in 1997 that wheeled exploration was possible. Then came Spirit and Opportunity, the twin rovers that outlasted their 90-day missions by years, uncovering proof of long-lost brackish water. Opportunity's final message: my battery is low and it's getting dark, read like a eulogy for a machine that had become family. Curiosity, landing in 2012, took the search to new heights. Its drill sampled clay-rich rocks near Mount Sharp, detecting organic molecules, the building blocks of life, and methane fluctuations that still puzzle scientists. But its perseverance, arriving in 2021, that's rewriting the playbook. With its helicopter sidekick Ingenuity scouting ahead, Perseverance isn't just analyzing rocks, it's caching samples for a future mission to bring back to Earth. Its landing site, Jezero Crater, was once a river delta, a prime spot for fossilized microbial life if it ever existed. The rover's instruments can even detect microscopic textures that might betray ancient bacterial mats, turning geology into a forensic hunt for fossils. Yet the real magic of these missions lies in their duality. They're both scientific tools and emotional touchstones. When Perseverance's parachute unfurled with the hidden message, "Dare mighty things," encoded in its pattern, it wasn't just engineering, it was poetry. These machines carry our collective yearning, transforming cold equations into stories of resilience. Every wheel track in the Martian dust is a testament to human ingenuity. Every pixel beamed back a postcard from a world we might one day walk ourselves. Mars reminds us that exploration isn't just about answers, it's about learning to ask better questions. Whether we find life or silence, the act of searching changes us. The rovers aren't just robots, they're extensions of humanity's restless spirit, crawling across an alien landscape so that one day we might follow. On October 19, 2017, the Pan-STARRS telescope in Hawaii spotted something extraordinary, a faint dot moving too fast to belong to our solar system. At first, astronomers assumed it was just another asteroid or comet. But as they tracked its trajectory, the truth became undeniable. This visitor came from beyond. Named Oumuamua Hawaiian for scout or messenger from afar, it was the first known interstellar object ever detected passing through our cosmic neighborhood. What made Oumuamua so baffling wasn't just its origin, it was its bizarre behavior. Unlike typical comets, it lacked a visible tail of gas and dust, even as it sped away from the sun at speeds that couldn't be explained by gravity alone. Its shape, inferred from brightness variations, was stranger still, a tumbling, cigar-like object up to 800 meters long but only 80 wide, spinning like a thrown javelin. Then there was the final twist. As it departed, Oumuamua accelerated slightly, as if pushed by an unseen force. Comets do this when their ices vaporize, creating jets, but Oumuamua showed no such outgassing. So what was nudging it forward? Theories erupted like supernova. Harvard astrophysicist Avi Loeb proposed the most provocative idea that Oumuamua might be artificial, perhaps a fragment of alien technology like a light sail propelled by starlight pressure. Others countered with natural explanations. Maybe it was a shard of a Pluto-like world, rich in nitrogen ice that vaporized invisibly, or a cosmic dust bunny compressed by interstellar gas. The truth we may never know. By the time Oumuamua was identified, it was already racing out of telescope range, leaving behind more questions than answers. Yet its legacy endures. Oumuamua shattered the assumption that interstellar visitors would be rare. Just 2 years later, Comet Borisov zipped through, proving our galaxy might be teeming with such travelers. New telescopes like the Vera Rubin Observatory, set to scan the entire sky nightly, promise to catch the next Oumuamua sooner, giving us time to study it in detail. What makes this cosmic narrative unforgettable isn't just the mystery, it's the humility it demands. For centuries, we've imagined alien civilizations might reach out to us. Oumuamua hints at a quieter truth. The universe might be tossing fragments of its untold stories our way, if only we're quick enough to catch them. Whether natural or not, this silent scout reminded us that we're part of a far grander, more dynamic cosmos than we'd dreamed, one where even the strangest visitors might be just the beginning. In December 1995, astronomers did something that seemed almost pointless. They pointed the Hubble Space Telescope at a patch of sky no bigger than a grain of sand held at arm's length, a region so empty it was thought to contain nothing at all. For 10 consecutive days, Hubble's lens stayed fixed on this void, collecting photons that had traveled across billions of years. What emerged from that gamble wasn't darkness, but a revelation, a single image bursting with 3,000 galaxies, each a swirling island of stars, some so ancient their light predated Earth itself. The Hubble Deep Field didn't just capture distant objects, it shattered our understanding of scale, revealing a universe so densely packed with wonders that even the emptiest corners of the sky were teeming with cosmic drama. What made this image revolutionary wasn't just the sheer number of galaxies, it was their variety. Some were elegant spirals like our Milky Way frozen in adolescence. Others were misshapen blobs caught in violent collisions or still forming from primordial gas. The faintest smudges, barely visible, were galaxies as they appeared when the universe was less than a tenth of its current age. For the first time, humanity had a visual timeline of cosmic evolution, a family album stretching back to the universe's toddler years. The deep field forced astronomers to confront an astonishing truth. If this tiny, random sliver of space held thousands of galaxies, the observable universe might contain hundreds of billions, each with billions of stars, each potentially hosting planets and perhaps life. But the real magic of the Hubble Deep Field lies in its paradox. By staring into apparent nothingness, we found everything. The image became a cultural touchstone, reprinted in textbooks, hung on dorm room walls, and cited in philosophical debates about our place in the cosmos. It's no exaggeration to say this single photograph did more to humble and inspire humanity than decades of lectures ever could. Here was proof that the universe wasn't just vast, it was alive, a dynamic tapestry of birth and destruction stretching far beyond our tiny vantage point. Later deep field observations only deepened the wonder. The Hubble Ultra Deep Field, released in 2004, peered even farther back in time, capturing galaxies from just 400 million years after the Big Bang. The E-Extreme Deep Field, a 10-year exposure released in 2012, reached back to within a hair's breadth of the cosmic dawn. With each new image, the message grew clearer. The night sky's emptiness is an illusion, a trick of limited human vision. The universe isn't mostly void, it's mostly story written in starlight we're only beginning to read. Perhaps the most poignant lesson of the Hubble Deep Field is how it redefined emptiness. What we once called nothing was in truth a vault of hidden treasure. Those galaxies, unseen for eons, waited patiently for a species curious enough to look and humble enough to realize how much more remains unseen. The image didn't just expand our knowledge of space, it expanded our imagination, reminding us that every time we point a telescope at the dark, we're not just observing the universe. We're introducing ourselves to it. On Christmas morning 2021, a rocket carrying humanity's most ambitious eye on the cosmos roared into the sky. The James Webb Space Telescope wasn't just another satellite, it was a time machine engineered to capture light from the universe's first galaxies, photons that had traveled over 13 billion years to reach us. Unlike Hubble, which orbited close to Earth, Webb positioned itself 1 million miles away at Lagrange Point 2, a gravitational sweet spot where it could float steadily, shielded by a sunshade the size of a tennis court. Its gold-plated mirrors, segmented like a honeycomb, were designed to detect infrared light, the faint, stretched glow of the most distant objects in the cosmos. What makes Webb revolutionary isn't just its technical prowess, but how quickly it upended our cosmic story. Within months of activation, it began transmitting images that left astronomers speechless. The Crab Nebula, a stellar nursery Hubble had rendered in ethereal blues, appeared in Webb's infrared vision as a swirling canyon of dust and newborn stars, its pillars glowing with crystalline clarity. The Southern Ring Nebula, once a hazy smoke ring, revealed intricate structures, shells of gas ejected by a dying star, swirling in patterns no model had predicted. But the real shock came when Webb peered into the so-called empty patches of sky for its first deep field. There, smudges of light previously dismissed as noise resolved into fully formed galaxies, their shapes crisp and mature, existing a mere 200 million years after the Big Bang. This discovery threw astrophysics into turmoil. According to prevailing theories, the universe shouldn't have had time to assemble such massive, well-ordered galaxies so soon after its birth. Some researchers scrambled to tweak cosmic models, suggesting early star formation was far more efficient than we thought. Others wondered if dark matter played a stranger role in galaxy assembly than anyone predicted. Webb didn't just add new chapters to cosmic history, it demanded we rewrite the early pages entirely. Beyond distant galaxies, Webb's instruments have turned exoplanet studies into an art form. By analyzing starlight filtered through planetary atmospheres, it detected water vapor swirling around the gas giant WASP-96b, over 1,000 light-years away. In the TRAPPIST-1 system, Webb spectra ruled out thick hydrogen atmospheres on several Earth-sized worlds, narrowing the search for habitable conditions. These aren't just scientific bullet points, they're clues in humanity's grand detective story, each observation peeling back another layer of cosmic possibility. Yet Webb's greatest gift might be its ability to make the unimaginable tangible. When it captured the iconic pillars of creation in infrared, the once opaque columns of dust became translucent, backlit by countless nascent stars like fireflies in fog. The telescope's image of the Cartwheel Galaxy, a chaotic ring-shaped collision of two galaxies, showed shockwaves rippling through interstellar gas in unprecedented detail. Even Jupiter, our well-studied neighbor, appeared transformed under Webb's gaze, its auroras and high-altitude hazes rendered in eerie clarity. What makes this era of astronomy so electrifying is how Webb bridges the technical and the poetic. Its data fuels PhD theses and supercomputer simulations, but its images ignite something deeper, a visceral reminder that the universe isn't just equations and redshifts. It's a living, evolving tapestry, and for the first time, we're watching the loom at work. Every photon Webb collects carries a message from the depths of time, whispering secrets about how galaxies assemble, how stars are born, and perhaps how life might arise elsewhere. The telescope's mission is slated to last a decade, but its impact will echo for centuries. Like Galileo's first glimpse of Jupiter's moons or Hubble's revelation of an expanding universe, Webb is redefining what's possible. It proves that when we dare to build instruments capable of seeing beyond our current understanding, the universe always answers with new mysteries. And in that endless dialogue between human curiosity and cosmic wonder, we find not just answers but better questions. Right now, the Andromeda Galaxy hangs in our night sky as a faint, fuzzy smudge, a neighbor so distant its light takes 2.5 million years to reach us. But this serene view is an illusion. In 4 billion years, Andromeda and our Milky Way will be locked in a gravitational embrace, two cosmic titans destined to collide, merge, and reshape the future of our galactic home. This isn't science fiction, it's an inevitability written in the motions of stars, confirmed by decades of painstaking observations. And while the timescales are beyond human comprehension, the story of this collision reveals something profound. Even galaxies, those seemingly eternal islands of stars, are fleeting players in the universe's grand dance. The evidence for this cosmic rendezvous comes from precise measurements of Andromeda's movement. Unlike most galaxies that redshift away from us as the universe expands, Andromeda is hurtling toward the Milky Way at nearly 250,000 miles per hour, pulled by the irresistible tug of gravity. Hubble Space Telescope data nailed down its trajectory, showing there's no escape, just a slow, inexorable spiral toward collision. But don't picture a catastrophic crash. Galactic mergers are less like car wrecks and more like slow-motion ballets. Over billions of years, the two galaxies will sweep past each other, their gravity stretching out long, luminous tails of stars, gas, and dust. Then, like partners in a dance, they'll swing back, intertwining again and again until they settle into a single, elliptical galaxy some astronomers have nicknamed Milkdromeda. What's astonishing is how little this merger will disrupt life on Earth, assuming humanity still exists by then. The distances between stars are so vast that our solar system will likely sail through unscathed, though the night sky will transform beyond recognition. Imagine looking up to see Andromeda's spiral filling the heavens, its dust lanes and star clusters glowing brighter as it draws near. Over time, new constellations will form from the mingled stars of both galaxies, and the Milky Way's familiar band will dissolve into a dazzling, chaotic haze. This collision isn't unique, it's part of a pattern as old as the universe itself. Galaxies grow by merging, a process we've witnessed across the cosmos. The Hubble Deep Field revealed countless galaxies in various stages of collision, their shapes distorted into tidal bridges and rings. Even our own Milky Way bears scars of past mergers, with streams of stars like the Gaia sausage remnants of ancient galactic feasts. Andromeda itself shows signs of a violent history, its halo littered with debris from smaller galaxies it's already consumed. Yet the Milky Way-Andromeda merger stands apart because it's ours. It forces us to confront the impermanence of even the grandest cosmic structures. The galaxies we see today, the constellations we've named and mythologized, are temporary arrangements. In the distant future, alien astronomers, or whatever inherits the universe, might gaze upon Milkdromeda with no idea that two magnificent spirals once existed. And that's the real lesson here. The universe is a place of constant transformation, where even the mightiest galaxies are fleeting brushstrokes in an ever-evolving masterpiece. So while 4 billion years is an unfathomable span, the Andromeda-Milky Way collision offers a humbling perspective. It reminds us that the cosmos doesn't exist for our benefit, it unfolds on its own timeline, indifferent to human scales of time and memory. But in that indifference lies a strange comfort. Long after our sun has faded and Earth's oceans have boiled away, the stars will still be weaving new stories, merging and evolving in a cycle as old as time itself. And in some small way, knowing that future exists that the universe will keep creating, destroying, and recreating feels like witnessing eternity. The universe is unimaginably vast, hundreds of billions of galaxies, each with billions of stars, many hosting planets in habitable zones. Given these numbers, the cosmos should be buzzing with civilizations. And yet, as physicist Enrico Fermi famously asked during a casual lunchtime conversation in 1950, "Where is everybody?" This simple question, now known as the Fermi Paradox, cuts to the heart of one of humanity's greatest mysteries. If life is statistically likely, why does the universe seem so silent? One possible answer lies in the sheer scale of space. Even if civilizations exist, the distances between stars are so immense that communication or travel might be practically impossible. Imagine two people whispering to each other from opposite ends of a football stadium. The message might never arrive, or it could be drowned out by the noise of the cosmos. Then there's the time factor. Civilizations might rise and fall in the blink of an eye on cosmic timescales. What if we're just not listening at the right moment, or others have already vanished before we could detect them? But the paradox gets even stranger when we consider the concept of the Great Filter, a hypothetical barrier that prevents life from advancing to interstellar expansion. Some believe the filter is behind us, meaning we've already beaten improbable odds just to exist. Others fear it's ahead. Perhaps all advanced civilizations inevitably destroy themselves through war, environmental collapse, or unchecked technology. The unsettling possibility is that the silence isn't a fluke but a warning. Not all explanations are so grim. Maybe extraterrestrial societies are deliberately avoiding us, adhering to a galactic prime directive of non-interference. Or perhaps they communicate in ways we can't yet perceive, using neutrinos or quantum entanglement instead of radio waves. There's even the chance that we're looking for the wrong things, assuming intelligence would resemble our own when it might be completely alien beyond our current comprehension. The Fermi Paradox doesn't just challenge our scientific assumptions, it forces us to confront our place in the universe. Are we alone? Are we first? Or are we simply not listening closely enough? With every new exoplanet discovered and every radio telescope scanning the skies, we edge closer to an answer. Until then, the silence remains one of the cosmos' most profound mysteries, a blank space waiting for humanity to fill it with either discovery or the humbling realization that we might be the only ones asking the question. Picture the cosmos as a grand, spinning carousel, galaxies whirling gracefully through the void, held in place by invisible ropes of gravity. But here's the twist: when astronomers tally up all the stars, gas, and dust in these galaxies, there's not nearly enough mass to explain their motion. The math simply doesn't add up. This cosmic accounting error led scientists to a startling conclusion. Most of the universe's matter isn't just hiding, it's fundamentally invisible. Welcome to the enigma of dark matter, the ghostly scaffold that shapes everything we see, yet slips through our detectors like a shadow through a sieve. The first clues emerged in the 1930s when Swiss astronomer Fritz Zwicky noticed something bizarre about the Coma cluster, a group of galaxies over 300 million light-years away. The galaxies were moving so fast that they should have flung themselves apart long ago, unless some unseen mass was holding them together. Zwicky called this missing ingredient Dunkel Materie, or dark matter, a term that would haunt physics for decades. But it wasn't until the 1970s that Vera Rubin's meticulous observations of spiral galaxies sealed the case. Stars at the edges of galaxies were orbiting just as fast as those near the center, defying Newton's laws. The only explanation, an immense halo of invisible matter, its gravity gripping stars like an unseen hand. Today, we know dark matter outweighs ordinary matter, the stuff of planets, stars, and you, by a factor of 5 to 1. It's the cosmic glue binding galaxy clusters, the hidden architect of the universe's large-scale structure. Without it, galaxies would never have formed in the early universe's smooth soup of particles. Yet for all its influence, dark matter refuses to play by the rules we understand. It doesn't emit, absorb, or reflect light. It doesn't clump like normal matter. It barely interacts with anything at all, passing through Earth and you. Like a phantom breeze, the hunt to unmask this elusive substance has spawned some of the most daring experiments in science. Deep underground, detectors like LUX and Xenon 1T wait in caverns shielded from cosmic rays, hoping to catch a rare collision between a dark matter particle and ordinary atoms. In space, the Fermi Gamma Ray Telescope scans for eerie glows that might betray dark matter particles annihilating each other. Even particle colliders like the Large Hadron Collider smash protons together at near light speeds, trying to manufacture dark matter in the lab. So far, all have come up empty, or worse, delivered tantalizing hints that vanish on closer inspection. Theories abound, each more imaginative than the last. Could dark matter be weakly interacting massive particles that barely touch normal matter except through gravity? Or perhaps actions, ultralight particles flitting through the cosmos like quantum fireflies? Some even suggest we've got gravity all wrong, that dark matter isn't a substance at all but a sign that Einstein's relativity breaks down on galactic scales. This latter idea, called modified Newtonian dynamics or MUND, remains controversial, but it speaks to how deeply this mystery has shaken physics. What makes dark matter so thrilling isn't just the scientific chase, it's the philosophical implications. We're forced to confront how little we truly see. The universe isn't just the glittering stars and glowing nebulae. It's a vast, shadowy ocean we've only begun to dip our toes into. Every time we build a better detector or telescope, dark matter recedes like a mirage, reminding us that the cosmos guards its secrets fiercely. Yet there's a quiet beauty in this pursuit. Dark matter isn't a failure of science, it's a testament to curiosity's power. For all our technology and knowledge, the universe still has the capacity to astonish us, to humble us with the realization that most of existence lies beyond our senses. And perhaps that's the real gift of this cosmic narrative, not just the answers we might one day find, but the boundless wonder of the search itself. The idea that our universe might be just one page in an infinite cosmic library is more than science fiction. It's a serious hypothesis that stretches the limits of imagination. Multiverse theory proposes that what we call the universe is merely one bubble in a vast foam of realities, each with its own unique laws of physics, constants, and perhaps even versions of ourselves. This isn't just wild speculation. It emerges from legitimate gaps in our understanding, like why the fundamental forces in our universe seem so finely tuned for life. If gravity were slightly stronger, stars would burn out too quickly. If the cosmological constant were smaller, galaxies might never have formed. The odds of such perfect balance seem astronomically low unless, of course, there are countless universes where the dice rolled differently, and we just happen to live in the one where the numbers lined up. One version of this idea comes from inflationary cosmology, which suggests that the rapid expansion of space-time during the Big Bang could have created pocket universes, like bubbles in a boiling pot. Each bubble might cool into its own reality with distinct physical laws. String theory takes this further, proposing the existence of 10 or 11 dimensions, with our universe confined to just 4, 3 of space and 1 of time. In this framework, other universes could exist mere millimeters away in higher dimensions, entirely invisible to us. Then there's the quantum multiverse, where every decision branches reality into parallel timelines, one where you turned left instead of right, one where dinosaurs never went extinct, one where the laws of chemistry themselves are unrecognizable. The implications are dizzying. If the multiverse is real, there could be universes where time runs backward, where light travels slower, or where matter never clumped into atoms. Some might be barren, lifeless voids. Others could teem with civilizations stranger than anything we've dreamed. Philosophers wrestle with the consequences. Does this diminish our significance or make our existence even more remarkable? Scientists, meanwhile, search for evidence, subtle imprints in the cosmic microwave background, unexplained gravitational anomalies, or patterns in particle collisions that hint at interactions with unseen realities. Yet the multiverse remains controversial precisely because it's so hard to test. If other universes are permanently beyond our reach, does the theory veer into metaphysics? Some argue it's no longer science, while others counter that indirect evidence like the fine-tuning problem demands an explanation, even if it's unobservable. The debate forces us to confront the very nature of science. How do we explore what lies beyond the horizon of detection? What makes the multiverse so captivating isn't just the science, it's the stories it inspires. It's the idea that somewhere, a version of you is living every road not taken, that every cosmic what-if might be real in another reality. Whether the multiverse is ultimately proven or not, it serves as a humbling reminder. Our universe, for all its grandeur, might be just one whisper in an infinite chorus of possibilities. And in that vastness, the most astonishing thing isn't that we exist, it's that we get to wonder about it at all. From the cold, silent depths of the solar system, a spacecraft turned its camera backward for one final glance. Voyager 1, having completed its grand tour of the outer planets, snapped a photo from 4 billion miles away, nearly 40 times the distance from Earth to the Sun. The image, taken on February 14, 1990, revealed something extraordinary: our planet suspended in a sunbeam, appearing as nothing more than a pale blue speck against the vast cosmic dark. This single frame, later immortalized by Carl Sagan as the pale blue dot, didn't just capture Earth, it reframed humanity's place in the universe with heartbreaking clarity. Sagan's words, penned in his 1994 book of the same name, transformed this grainy photo into a philosophical lightning bolt. "Look again at that dot," he wrote. "That's here, that's home, that's us. Every human who ever lived, every war fought, every empire risen and fallen, every whispered, 'I love you,' all of it confined to a mote of dust smaller than a pixel." The image strips away our pretensions of centrality, laying bare the truth. We are temporary residents of a fragile oasis, adrift in an indifferent cosmos. Yet instead of despair, Sagan found profound hope in this perspective. If we could see ourselves from this cosmic distance, he argued, our tribal divisions would seem absurd. Borders, ideologies, and conflicts melt away when viewed against the backdrop of infinity. What makes the pale blue dot so powerful isn't just its scientific value, it's its emotional resonance. The photo arrived at a pivotal moment in history. The Cold War's tensions still simmered, environmental crises loomed, and humanity's technological prowess outpaced its wisdom. Against this backdrop, Sagan's reflection felt like a wake-up call. The dot carried no visible scars of human strife, no smog, no bomb flashes, no deforestation. Just a shimmering blue marble, wrapped in delicate veils of atmosphere, protected only by the thinnest sliver of air against the void. It was a visual manifesto for planetary stewardship, a reminder that we share this tiny life raft with no backup in sight. Yet the image also sparked scientific wonder. That faint blue hue, sunlight scattered by our oceans, the only known liquid water in the solar system, the washed-out streaks of light. Camera artifacts from Voyager's long exposure, but poetically reminiscent of how starlight bends around the universe's hidden masses. Even the photo's accidental composition speaks volumes. Earth wasn't the intended subject. Engineers had turned the camera to capture a family portrait of the planets. Mercury was too close to the Sun to see, Mars lost in glare, and Pluto too dim. The result was a cosmic happy accident, a serendipitous snapshot of solitude. Decades later, the pale blue dot's legacy endures. It's been etched onto vinyl records, painted on murals, and referenced in everything from UN climate speeches to hip-hop lyrics. The image transcends astronomy. It's become a cultural touchstone, a secular icon of unity and humility. Modern missions like New Horizons have since captured more distant photos, but none carry the same emotional weight. There's a reason Sagan's words still echo. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Perhaps the most astonishing thing about this cosmic narrative is how it flips the script on exploration. Voyager's mission was to study the outer planets, yet its greatest gift was turning the lens back on us. The universe didn't shrink under its gaze, we did. And in that contraction lies an expansion of understanding, a visceral grasp of our true scale. The pale blue dot isn't just a photo, it's a mirror, forcing us to confront the bittersweet truth that we are simultaneously insignificant and unimaginably precious. A paradox written in starlight, waiting 4 billion miles from home. Imagine holding a snow globe in one hand and a microscope in the other, two entirely different scales, two separate worlds. Now picture trying to describe both with a single set of rules. That's the monumental challenge physicists face in their centuries-long quest for a theory of everything, a unified framework that can explain the cosmos from the dance of galaxies to the quantum flutter of subatomic particles. This grand pursuit didn't begin with equations scribbled on modern blackboards. It started with an apple's fall in 17th century England. Isaac Newton's law of universal gravitation was the first crack at cosmic unity. His insight that the same force pulling fruit from trees also guides the moon's orbit was revolutionary, a glimpse that nature's laws might be elegantly interconnected. For centuries, Newton's equations reigned supreme, predicting planetary motions with uncanny precision. But by the late 19th century, cracks appeared. Mercury's orbit wobbled inexplicably, and the mysterious forces of electricity and magnetism refused to fit the Newtonian mold. The universe, it seemed, was playing by more complex rules. Enter Einstein. His theory of general relativity in 1915 didn't just tweak Newton's ideas, it rewrote them, describing gravity not as a force but as the curvature of space-time itself. Planets didn't orbit the sun because they were pulled. They followed the grooves in a cosmic trampoline warped by mass. Meanwhile, quantum mechanics emerged to explain the atomic realm, where particles pop in and out of existence and electrons behave like both waves and particles. Both theories worked flawlessly in their domain's relativity for the cosmos, quantum mechanics for the micro-world, but when forced to coexist, they clashed violently. The conflict reaches its peak in black holes, where infinite density meets quantum uncertainty, or the Big Bang's birth moment, where the entire universe was smaller than an atom. In these extreme scenarios, relativity and quantum mechanics spit out nonsense equations that explode into infinities. This isn't just academic nitpicking, it's a fundamental rift in our understanding of reality. For decades, physicists have sought a bridge, a theory flexible enough to stretch across all scales. String theory emerged as a leading contender, proposing that the universe's fundamental building blocks aren't point-like particles but vibrating strings, each oscillation pattern corresponding to a different particle. The math is breathtaking, a symphony of extra dimensions, curled into shapes too tiny to detect, that could unify all forces. But string theory remains unproven, its energy scales far beyond current particle colliders' reach. Alternatives like loop quantum gravity take a different path, weaving spacetime itself from discrete, interlocking loops. Others explore holographic principles, suggesting our three-dimensional reality might be a projection from a two-dimensional boundary. What makes this search so compelling isn't just the science, it's the philosophy. A theory of everything wouldn't merely fill textbooks, it would redefine our relationship with the cosmos. Are we living in a multiverse where constants vary? Is time an illusion emerging from deeper physics? Every failed experiment and mathematical dead end teaches us something profound. The universe resists simplicity. Yet the hunt continues, fueled by the belief that beneath the chaos lies an order waiting to be deciphered. Whether the answer arrives in our lifetime or not, the quest itself stands as a testament to humanity's audacity, to stare into the abyss of the unknown and demand clarity. Stephen Hawking once wrote that his goal was a complete understanding of the universe, why it is as it is, and why it exists at all. Few scientists have come closer to that monumental ambition while simultaneously capturing the world's imagination. His story isn't just about equations scribbled on blackboards. It's about how a mind confined to a wheelchair became the most recognizable voice of cosmology since Einstein. Diagnosed with ALS at 21 and given just 2 years to live, Hawking defied every expectation, not just surviving but revolutionizing our understanding of black holes, time, and the universe's origins, all while becoming a cultural icon who made science accessible to millions. Hawking's brilliance first shone through his work on singularities, those infinitely dense points at the heart of black holes where Einstein's equations break down. In the 1960s, he and mathematician Roger Penrose proved that such singularities weren't mathematical quirks, but inevitable consequences of general relativity. Their theorems showed that if you reversed cosmic expansion, you'd hit a singularity, a big bang implying time itself had a beginning. This wasn't just abstract physics, it edged into philosophy, suggesting the universe had a creation point, a notion that thrilled theologians and scientists alike. But Hawking's real bombshell came in 1974, when he proposed that black holes aren't the cosmic vacuum cleaners we imagined. Through quantum mechanics, he showed they could slowly leak energy, now called Hawking radiation, evaporating over eons until they vanish in a final burst. This idea bridged relativity and quantum theory like no work before it, hinting at a deeper unity in physics. The scientific community was stunned. Black holes, long thought to be eternal traps, had an expiration date. The implications were profound. If information swallowed by a black hole was lost forever, it violated quantum mechanics' core tenet that information can't be destroyed. The black hole information paradox became one of physics' fiercest debates, with Hawking famously conceding in 2004 that information might escape after all, a U-turn that showed even giants remain students of the cosmos. Yet Hawking's genius wasn't confined to journals. His 1988 book, A Brief History of Time, sold over 10 million copies, turning dense concepts like entropy and string theory into dinner-table conversations. With wit and simplicity, he explained why time only flows forward, how black holes glow, and what might lie before the Big Bang. The book's success revealed a public hungry for cosmic wonder, proving science didn't need to be dumbed down. It needed to be illuminated with clarity and passion. His later works, like The Universe in a Nutshell, used vivid illustrations to unpack multiverses and M-theory, while his documentaries and cameos on shows like The Big Bang Theory made him a household name. Hawking's cultural impact transcended academia. His robotic voice, synthesized after losing his natural speech to ALS, became iconic, a symbol of resilience. He soared into zero gravity aboard a modified jet, floated in his wheelchair during the 2012 London Paralympics opening ceremony, and warned about AI's existential risks with the urgency of a prophet. His life embodied a paradox, a man physically trapped by disease who explored the cosmos more freely than any astronaut. The legacy he leaves isn't just in papers or prizes, but in the millions he inspired to look upward and ask big questions. When he passed in 2018, his ashes were interred near Newton and Darwin in Westminster Abbey, a fitting tribute to a thinker who reshaped our cosmic narrative. But perhaps his greatest monument is the curiosity he ignited. In a universe that can seem indifferent, Hawking showed that the human mind, no matter how fragile its vessel, can grasp toward infinity. His final message to humanity: remember to look up at the stars and not down at your feet, a call to wonder that echoes long after his voice fell silent. These 25 cosmic narratives are more than just stories. They're a testament to the unbreakable bond between humanity and the heavens. From the moment our ancestors first traced constellations in the flickering light of campfires to the modern era of quantum physics and interstellar probes, the cosmos has been our grandest classroom, our most humbling mirror, and our greatest muse. Every civilization, every generation has looked up and seen something different in those glittering depths, omens, gods, equations, or frontiers, but the thread connecting them all is the same: an insatiable need to understand our place in the vastness. What makes these tales unforgettable isn't just their scientific significance, but how deeply they're woven into the fabric of who we are. The Star of Bethlehem guided not just wise men, but centuries of art and faith. Galileo's defiance reshaped not only astronomy, but our very notion of truth. The pale blue dot didn't just redefine our planetary perspective, it redefined our humanity. These aren't isolated events, They're milestones in an ongoing conversation between the universe and the tiny, curious beings trying to make sense of it. And the conversation is far from over. Right now, telescopes like James Webb are peeling back layers of cosmic history, while rovers on Mars drill into rocks that might hold fossils of ancient life. Citizen scientists comb through data, uncovering exoplanets from their living rooms. The next groundbreaking discovery could come from a PhD student's late-night calculations or an amateur astronomer's backyard telescope. That's the beauty of this story. It's still being written, and everyone's invited to contribute. So as we wrap up this journey through space and time, here's the real takeaway. The universe isn't just out there. It's in us. It's in the way a meteor shower makes us gasp, the way a theory of everything tugs at our imagination, the way a single photo of Earth from space can unite strangers across continents. The heavens have shaped our past, but they also hold our future, not just as a destination, but as an endless source of wonder. Now it's your turn. Which of these cosmic tales resonated most with you? Was it the mystery of Oumuamua, the audacity of Voyager's golden record, or the quiet revolution of the Hubble deep field? Drop your favorites in the comments, and let's keep the conversation going. And if you're hungry for more deep dives into the universe's greatest mysteries, hit that subscribe button, because this is just one chapter in a story that stretches to infinity. The stars may be billions of years old, but our journey to understand them, that's only just